Hello.
Hello.
Oh, there you are. Okay. Weird.
Oh, this means being recorded by the host. Maybe I'll leave. I don't want my face to be known on the interwebs.
Says the guy who has his face plastered all over the interwebs.
True. I guess it makes the least sense for me to say that out of anyone here. I will post my face in more places. Thank you very much. Or at least my name. Get the credits and more stuff.
Oh, 1 second. My second screen isn't working. Oh, here we go. Okay. That's weird.
Missing a Tyler.
Missing a Tyler.
Oh. I think I just have a Zoom link.
Ooh, nice.
Finished the during lunchtime the business video, that one video you shared for lunchtime viewing, and very insightful. Definitely helps frame a few things that I need to do in a different way.
Awesome. Wait, you guys are ready? Okay, I'm gonna share screen. And
Poor kid.
Poor kid. Ooh. Oh.
I don't see the recording. Pause.
Hold up 1 second.
Is it already recording?
I'm pretty sure. I
It's
saw,
been recording since we
Everything
joined.
recording.
are we gonna be
Oh.
those old people in the videos now where it's like, oh, is this a
It
recording?
says it's recording top left corner.
I know.
No,
how
we'll
to-
just skip up to this bit.
My son does not want to go down for nap time.
Oh.
And now that actually we transitioned him from crib to his own bed, he just get up and
Oh.
walk out whenever he wants to.
Oh, that's the worst. So
Yeah.
bad. The rest.
So we're
don't know
dealing
how
with that
terrible.
now.
The crib was the best. You just drop them in and walk away, and eventually they sleep. But now I just get out and explore the room. Yeah. Okay.
Potentially hazardous things that you can't see.
Okay. So this is coming out of Tyler's question. I forget exactly the context. We were discussing something that he was working on, and I was making some suggestions, and I was like, no, this is, you know, how you make robust code. And he's like, what does it even mean? What does that mean to write robust code? I thought that was a pretty good question. And then I started digging into it, and it's really fuzzy question to answer, because there's stylistic things, there's structural things, there's, I don't know, like consideration for, there's consideration for others. So I spent a lot of time looking around and boiled it down to this. So I'm going to start with an example of brittle code. So this is brittle code, and what is it exactly? So what makes it brittle code? First thing is this code works. So what is it? It's calculating a discount for a particular customer. So, hey, they're placing an order and they're this kind of a customer and they've been this kind of a customer for this many years, whatever, and here's the discount that we give them. So does it work? Yes. Will it pass a university course assignment? Probably. But if we change one little thing about this, it breaks. There is a non-obvious bug, which is what happens if the customer type, which is an int, what if it's 0? What if it's 5? Do you know what happens? Tyler's muted. He's talking away.
It just
Like a
returns the
discount.
result.
Yeah, of 0.
But from the business, what happens to the business?
They get no money, I assume.
Yeah, you're giving away free product. So this is deadly serious, right? Your discount engine is giving away free product. And how many free product orders do you take before you realize all these orders are going out for free, right? I worked at grocerygateway.com and I can tell you it's many orders that before someone realizes, wait a minute, this doesn't make any sense.
Was this actual code from Grocery Gateway?
No.
Okay.
No. I don't have that code, and it would take hours to source up something like this. So that's pretty terrible, right? In terms of like how brittle this code is, the tiniest change, and something unexpected by the original developer causes free products to go out. It doesn't throw an error, doesn't break that way, but it breaks the business. And so that is a consideration for brittle code, right? So don't just put on the comp sci blinders. As far as like still compiles, what are you talking about? Code's not brittle. So, okay. So is it the fault of the writer of this function that it's so brittle? Technically, no. It does exactly what he or she was asked to do, but in reality, yes. And the reason I say yes is because there are ways of programming this to avoid that issue of giving away free products if the data is slightly different than the original writer intended. Okay, so what we can at least do is alert the caller, the person who's calling calculate, we can alert them things are not as I expected, right? So that's the first kind of step of making something robust, is that you can at least code your assumptions into the function. And now we're going to talk a bunch of theory, and then we'll come back to looking at this thing. Okay, so robust code. The first one is not robust code. So it's perfect or it fails. And robust code can handle differences. That's what the gradient's trying to show, that hey, it may not be perfect data, but I can still work with it. And then at some point it does fail because of base assumptions that you can't get around. But that's the big difference. So fragile is black and white. Robust doesn't have such strict expectations. It can handle many state changes before breaking. Okay, so you might think of this as versions and like changes that occur. So it's like, yeah, okay, we're good. It starts to get more and worse before it needs a rewrite, a refactor, but it can handle it. Whereas the first one, and like any change, it just busts the thing. Okay, so I gave away all my answers. So fragile code is hard to change. Robust code is easy to change. That's the first criteria. Second is fragile code immediately breaks in slightly different uses. Robust does one thing well, so it doesn't matter how you use it. So that's really important. Fragile dependencies on process flow, use, or magic values. And the or there is, it's an and or. It could be all those things, or just one of those things. And robust has no magic values. Fragile code, complexity kills. Robust code is usually simple, and that's what lasts. And I skipped one, which is no race conditions for order. So this dependency on process or flow, you'll see this in a second, but what I'm talking about is state changes. So I have to call this and then call that second thing, because if I flip the order, the state changes aren't there, and then the thing blows up or whatever. Like and so you want to try to create methods, functions that are state independent, that they can be called, and it kind of doesn't matter the order with them. And so you'll see this in a second, where why you use parameters versus relying on class member fields, so that you can call them in any order and you're not reliant on state. But the big one is that if it's complex, it's probably fragile. And if it's simple and does its one thing well, then it's robust. And I know that the simplicity and does one thing well can be taken to a vomit level extreme of there's one line to every function and there's 1,000 functions on the class, and that is insanity. And I never want you to program that way, and I'm never asking you to do that, even though you'll see these extreme examples on the internet. Okay. So I didn't take time to put all my animations, make them look nice, so you can just wonder what these berries are here for. But the only valid measurement of code quality is what the fruits per minute. Okay, so when somebody's looking at your code and they're like, what the berry per minute? And if that's a low number, then it's good code. And if it's a high number, then it's bad code. So the first is what the berry, and discuss this code is not required. Why is that even there? Okay, the next one is what the berry in terms of admiration. This guy's super smart. Okay, this code is like beyond me. And the third is what the berry in terms of exasperation, unable to understand this gibberish. So you want to minimize your what the berries per minute when somebody goes and looks at your code. So the rest of this talk is how you do that. Okay, so programs must be written for people to read and only incidentally for machines to execute. That is the most important thing here. Why? I say that as your employer. The amount of time that you spend, that I pay you a wage and you're spending trying to understand code, that has a material cost to the company, to the product that we're making, right? So it is much, much better to write code that is easy for people to read, and it's great that the CPU can run it and execute it on things. So that's why you'll see the code is done in certain ways, or maybe even not optimal ways. And there's a lot of tricks in the past that you needed to do. I'm talking the way past, where you need to do with variable names and stuff, that you need to have short variable names in order to save memory for the compiler, because you could exceed the memory of the compiler and you can't compile your program anymore, right? So you'd have to like shorten these things down. We obviously don't need to do that anymore, right? And so that's a great example where you can have a 256 character variable name if you want. If somehow that's enhancing readability, I can't imagine 256 characters is enhancing readability, but the point remains that it's possible. So we write code for people, and then we happen to run it on computers. Who's the audience? Who's the audience of this code that you're working on? This is the biggest difference between school and personal projects and professional work. So you need to program for me and Michael and Sean and Tyler and Zach and Josh. That's who you're programming for. You're not programming for yourself anymore. You are programming for the team. So when you're programming for someone else to take it over. Okay, there's two rules that I use. The first is someone else is going to have to change this. Why? Because I'm either gone or I'm busy, which amounts to the same thing, which is I can't do it. Right. So you write your methods, you follow our styles, and I'm not going to talk about styles really in any of this because the styles are very studio kind of dependent. But you write your code for someone else to modify it. And that's where code commenting comes in. It's like, okay, well, somebody else isn't going to know about the bug I found where if you do it this other way, it actually doesn't work because it creates this weird else condition where it actually breaks. So I made it this way, and then you throw in a comment, it's this way because it's a bug if I do it the other way, right? Like that's super useful to the person who has to come in and start modifying and go, why did they do it that way, right? Like what the fruit is that? So that's what you're programming for everyone else. You're not programming for yourself. Okay, the next thing to address is this idea of future-proofing and roughing in a bathroom. So I am in a basement office that we renovated. So when we bought the house, it was studs and concrete. And if you know anything about the pouring of concrete, you don't have to know much to know this, but when you pour concrete, it's very malleable at the beginning. And then over time, it hardens and you ain't changing it, right? You got to get the jackhammer out. And I've seen people work on concrete on my house, and they got the jackhammer out and they got the concrete saw out. And it is a lot of dust and a lot of mess and a lot of noise, and maybe even some crying when you have to change things that are in concrete. Okay, so the people that built this house that I'm in, they roughed in a bathroom. So what does that mean? That means before they poured the concrete, they ran the pipes for hot water, cold water, and sewer, so that when somebody in the future wanted to install a bathroom, they didn't have to cut concrete. They need to do that. So how do you know whether you are over engineering or you're roughing in the bathroom plumbing? Because roughing in the bathroom plumbing costs you very, very little. And I did this also with propane. So I have a, I'm at a window, I'm at the one side of the house. There's the propane tanks outside the house for heating water and for cooking. And I thought, oh, maybe I might want to use that for my furnace. Right now, an electric furnace, I might want to use a propane furnace in the future. So before we finished up everything, I ran propane pipes all the way across the house to the utility room to where the furnace is, and that's where they stop. They're not connected to anything. What did it cost me to do that? $200. What does it cost me to say, oh, I want propane for my furnace? Oops, we don't have a propane connection here. $10,000 to $20,000 in terms of all the ripping out, all the work, and having to re-drywall and repaint and cleaning and whatever, right? So it's the 200 to 20,000 kind of determination. So you rough something in when it's extremely low cost and it's saving you a ton later. That's when you know to rough it in. Otherwise, you don't do anything. And that's what the next slide is. So we do want to rough in the pipes before we pour the concrete, but we don't want to go any further than that. And so that brings us to the question of future-proofing and extreme programming. It's one of the best books ever written. I fell in love as I was reading on an airplane in, I was around 2002, 2000, yeah, around 2002. I think it came out in 2001. Is that the one by Kent Beck? Who wrote that?
It's a little pocket guide, but it was written by, see, say.
Okay, well, it should be on the front as to who wrote it, unless it's like a rewrite, like
Yeah.
somebody condensed it down or something.
It's an O'Reilly book, forward by Ward Cunningham.
Okay, so extreme programming has excellent principles. This is where test-driven design comes from, automated test comes from. It's all from this singular amazing book called Extreme Programming. And they address the issue of this concept of future-proofing. It came up in a meeting that we were in recently. And it was like, oh, well, okay, we're going to do this thing, and then maybe we'll want to do this, and maybe we'll want to do this, and maybe we'll want to do that. How do you know what to do? And the answer is, in extreme programming, just what you need today. just what you need today. That's it. Don't worry about the future. Don't worry about the next guy. You're like, wait a minute, you just told me I'm programming for the next guy. That's right. That's why you have to balance these rules, right? And so you are programming for the next guy, but you are programming just what you need today, and don't worry about it. And so, you know, we could spend a lot of time future-proofing and making powerful code that can deal with any possible situation. Wrong. Nobody can predict the future, and wrong again, because it'll be complicated, unmaintainable mess. So just what you need today. And all these what if scenarios, what if, like we just talked earlier, Sean had an amazing idea. We could componentize all these things in Archmage, like the phishing, and what if we could just plop that into Archmage 2? And the answer is no, you don't do that. You just program the phishing that you need today. And then when we get to Archmage 2, we might decide, yeah, that phishing sucks. We don't actually want to do phishing, right? And all that work you put into making it all componentized and beautiful to drop into any game was a waste of time, right? Because business reasons change. Maybe coding reasons don't change, right? And so, but business reasons change. It's like, oh, that feature was like the worst feature of the game, and we just got slammed all the time in the comments. So we're just going to not have phishing, and then have people have anything to complain about. We took the phishing out of the save file, and we saved 80%. So we'll take the phishing out of the game and drop 80% of the negative comments. So don't worry yourself about what if situations. Focus on what you need today. And so that's the rule of Yagni. Yagni is you ain't gonna need it. You ain't gonna need it. Okay, so that's how you address this desire, this engineering desire inside you to future-proof things and make it so beautiful, wonderful. It does a million things. It's the Swiss Army knife of functions now. You can call in any of these scenarios and it'll just do the right thing. Okay, because you have very, very little ability to view into the future, but hindsight's 2020. So when somebody goes to need to extend a thing, they know exactly what they need to extend it for. They ain't guessing. The thing doesn't work anymore and it's not fulfilling some need, and I have to extend it to meet that new need. That's when the person goes in. So as long as you've programmed for the next guy, and you haven't made anything superfluous and unnecessary, when this next guy shows up to do the thing that you never imagined this function method would ever need to do, they don't have to deal with all this extra code, unnecessary code. They don't have to deal with variables that don't actually matter. And they don't have this, you know, I'm imagining instead of being 80 lines, it's only 30 lines because it doesn't do all this extra stuff. And so when that person comes to extend it, there's only 30 lines I have to worry about in terms of extension. Okay. So next is the first order of business. Get it working or make it readable? That's a pretty good question. Does anybody want to vote on that? Get it working or make it readable?
I would start with get it working and then make it readable. Because if you have unworking code that's readable, it's useless. But if you have working code that's not readable, at least you have something to make readable.
Yeah, I agree with that. Uncle Bob doesn't know. He says code formatting is about communication. Communication is the professional developer's first order of business. And so if you're thinking getting it working is the first order of business, then you may not actually make it readable. You may not get the time. You may get fired or moved on to other things or something.
There are many times where that has happened on projects I've been working on, where I'm like, hey, I'm working on this thing, and then now I have to go work on something else. And so that second pass of making it clean or usable never happens.
So he says functionality you create today is likely to be changed next release, but readability will never change. So if you start with readability, that won't change. Okay, next. So let's take a look at this really simple example. This is extremely made up example in order to prove some points. So it does mimic somewhat Archmage, that you're casting a spell and we need to know, okay, how much power is it going to take when you cast the spell? What's the power that comes out of this? And so we're passing in some stamina usage, passing in the spell, and then we're saying, hey, if the caster's a player, for some reason, through balancing or whatever, we figured out that really the power should be the damage ×2. And if you're not the player, then spell damage should be halved. Okay, doesn't matter why those things are. And then we if for some reason you got here, which you never would, you would get a compiler warning on this because you're returning in both these things. But anyway, just whatever case we're handling a 0. Okay, so the thing I want to zero in on is where the berry is this caster thing coming from, because this is totally outside of this method, right? I got stamina and spell, and I can see I'm using the spell damage. I didn't actually end up using stamina. Don't just ignore that. That's not important. But I'm using this caster thing, which is never even passed in. And that is making this method dependent on class state. And class state is controlled somewhere else outside of this method. And so this is where you're creating problems for yourself, because there could be lots of reasons why the caster is not equal to player, and you don't know, and you have no control over it. So you're just calculating this out. So if you're in that situation, you want to make state independent code, right? Nothing outside the method is being used. And so here we just pass it in as a parameter, and now it's really explicit. Okay, does this compile? Of course it compiles. Does this work? Yeah, look at me. I saved a variable. I'm reusing a variable. So it's more memory performant because I don't have to cast and pass around this caster thing. I'm just referencing it. But here, okay, yeah, I have this extra parameter that I have to call where I'm passing through the caster. But now it is totally self-contained. This can be plugged in anywhere, and it doesn't rely on any state anymore. So you can even move it across classes if you wanted to. So that is.
You've just got the player there. Doesn't that still make it state dependent?
No, I'm focused on this caster thing, right? Caster equals player. Player is a type.
Okay, right.
Okay.
Yeah. So this is what's important. All of the things that I'm using in my logic came to me. I can see them coming through, right? Where, like, when you're in your watch area down in Visual Studio debugging, you know, it's going to show you what all your parameters are. You can mouse over all the parameters. But going to the previous one of, hey, well, where's this caster thing coming from? You got to go figure out where this thing is. And I know it's super simplistic here, but that's what creates problems for yourself. Oh, wait a minute. Something elsewhere is changing the caster thing right before I go to calculate the power. That's no good. Okay, so the next thing we can do to improve this is dry or die, which is don't repeat yourself, or also known as duplication is evil. So if we go back to this code, we are taking spell damage and multiplying it ×2. We're taking spell damage, multiplying it by 0.5. Okay, so it's halving and it's multiplying. So if we apply this, we don't do that anymore. We create a damage modifier. Hey, look, we're using more memory. This is less performant. Well, I told you earlier, I don't care because it needs to be readable first. So we have this damage modifier. We started off as 1, which is not modifying at all in terms of multiplication. Hey, and then we change our damage modifier, and then we do one calculation. So you set it up, and then you get one line of execution logic. So the actual logic of this thing is here. And you're like, okay, great. And my point is, when this gets more complicated, because it will, now you only have to do this in one place, right? On that one line. Whereas if we had kept it the other way, I have to go and do this thing twice. And that copying and pasting, I might mess something up. I do that all the time when I have option 1, option 2. Yesterday I was working on a little website thing, option 1, option 2, option 3. And I cut and paste option 1, paste. And then I noticed, oh, I forgot to change it from option 1 to option 2 to option 3. And so my code was checking the length of the option 1 array and on the third option choice because of my lousy cutting and pasting. Okay, but if I only have one place where I'm doing my execution code, my complicated execution code, then I never have that issue. And so that's why you never want to do that. So this code is now more robust. It's more robust. And then, but there's obviously still more that needs to change. And that brings us to the rule of no magic. We're making a game about magic, but you're not allowed any magic inside the code. So no magic. And we want to remove all the magic numbers. So you remove the magic numbers, and we no longer down here have these halves and twos. We now have a much more explanatory thing than a 2, which is the power for a player, a power for monsters, and a power for default. And so it's the exact same logic, but now it's like, hey, the damage modifier is now equal to a power player or versus the power of monsters. And so this is way more readable than our numbers before. It also makes a nice little thing where you're setting up your variables. So if you do need to change these things for tuning reasons, or if you are reading these in from external files, right, we have a nice place in which to do that. And then down here, we do our execution. So we have our setup, we have our logic, and then we have our execution with the result of our logic. This is starting to almost read like pseudocode. That is a good sign that you are on the right track when it looks like pseudocode. The more you can basically Englishify your code, then you're on the right track. Another thing that we did here, which is another rule, is you want to apply constraints. You'll see this later. You want to apply constraints and you want to minimize variability. So we've removed the magic numbers and we've removed the variability of the magic numbers. If I tried to change the player power and I accidentally did a ++ on it before I went and used it, it would throw a compiler error, right? Because I did it. I made it a constant. So that is making this code more robust. Nobody can change these values after I declare them. That's more robust code. Okay.
Just sorry on that. Is that like, I was just thinking about your like, you ain't gonna need it kind of thing.
Mm-hmm.
This kind of implies that, well, there's a power default that never gets used as such.
That's
or
right.
rather, yeah, so isn't that sort of like future proofing? I'm just trying to get my head around this. Isn't that kind of future proofing in a way that we're not meant to, or if that kind of makes sense?
Well, I need to initialize the value to something, and I'm trying to, show that you don't use magic numbers. So, right, what do you initialize to? 0, 1?
No, what I mean is like we've got this power monsters, and
Yeah.
anything that, what the implication of this code is right now is that anything that isn't the player is a monster, I suppose, but that may not strictly be true.
Yeah.
Is that misleading and is that bad, or is it fine? I'm trying to get my head around that a bit.
I would say don't worry about that so much in my little sample that I whipped up to try to make some slides. I was trying to show that, you initialize something to some value. Well, I could initialize it to 1, but here I'm calling it power default. And then, yeah, in my simple case of if and else, because I'm trying to set up a bug later. So
okay, cool. Thank you.
This is all just made up. Okay, so you want to set things up at the top and then let it run. This code here, we have a constant for our power default, and then we initialize to it. And then we declare another constant for the power player 2 and power monsters here. And then we do some stuff with that. And then we get to the end of the code. So my point here is we didn't set up top and then let it run. We basically declared variables as we needed them. And so I can look at this and immediately tell this person never refactored. This was stream of consciousness coding, and they never went back and went over it and go, oh, actually, I'm just going to move these things up here. So I got all my variables all nicely initialized before I go and start executing my code. Okay, so yeah, So what you want to do is you want to treat it like a wind up robot, right? You set up your things up top and then just let her rip. Okay, then the next thing is definitely more on the style side of things. So let's talk in terms of language. So what is a sentence? A sentence when you're writing is a single thought. Okay, great. So paragraphs and topic sentences. So a paragraph is a series of sentences that are organized, coherent, and are related to a single topic. This is how we write anything. I don't think that's just English. I think that's true of any language. Although, since I really only speak one language, I don't have the authority to say that, but I'm pretty sure the principle is universal. So you have a singular group of thought, and then you break, and then you have new paragraphs. So paragraphs show a reader where the subdivisions of an essay are, helping the reader to see the organization of the essay and grasp its main points. So when we go and we look at this code, you can see that we're grouping things. So get the list from the forums. I don't even have to read all this because the breaks show me that this is get the list from the forums and this is the code to get the list from the forums. Then I load the templates and this is the code for loading the templates. So I don't really need to read through the code. And first of all, nobody ever actually reads every single line. Everybody skims, everybody reads the first thing. It's the way our brains are wired. So what you're doing by making this is you're doing what's called chunking. And that's how our brain utilizes things as common important thing in UI is the chunking of information. And so when you especially when you throw in the comment, although the comment isn't necessary, but it does help, it chunks up the code for the next guy, right? You may not need it, but it helps the next guy know, oh, this is where this stuff is, this is where this stuff is, this is where this stuff is. So when they go through and they're looking for a bug or they have to extend it, they kind of know where the separations are. So obviously each line of code is a sentence, and then we make breaks to make paragraphs as you're going along. So the white space is not random in what we're doing. Thanks, Yuri. Okay, so the next one is to write assertions for assumptions. So we made an assumption in this, and so we want to be very clear about our assumptions, and that's what the asserts are for. So the assertion fires if it's false. Okay, so if the caster is equal to the player type or the caster is equal to the monster type, if it's equal to one of those things, then we're fine, nothing happens. But if you get some new type, somebody introduced some new type, going back to that original code example where they introduced some new customer type, then we're going to get an assert and immediately be notified. An assert basically throws as an exception. You can configure that, but it throws as an exception. So it's like an exception without it actually being an error. And then you can catch these things right away. So, you're writing your little power function and you're like, these are my assumptions and I'm going to make an assert for those functions. I don't care about doing this too strictly, like every method you have to have asserts for all of your assumptions. I'm not saying that because programmer time is very valuable and I don't want to waste it on that. But in this particular case, I have some very clear assumptions, and I know when I'm writing this thing, hey, it's going to break if there was any other kind of caster. So that's why we want to do that. Okay. The next one I want to show is applying dry for function overloads. So function overload is the ability to have basically the same method. It shows up as the same method, but it takes a varying number of parameters. Okay, so you have different, that's what it means by overloading it. So we take a different number of parameters, but it's doing essentially the same thing. So this is very common. Here we have something that's in a utility class, list to string. Okay, great. It goes through and it takes this list and turns it into a string. So this one does it, takes a list, turns it into a string, does it with a comma. This one does exactly the same thing, but allows the person to specify the kind of delimiter that they want to use. Okay, so that's reasonable. Sometimes I don't care. Sometimes I really care. I want to use dashes. I don't want commas, right? And so you have to extend the function. in order to do that. As this is written, this is completely horrible for the do not repeat yourself, right? And so the proper way to do it is like this, which is what actually is in our source code. I think Michael wrote this, so he was like all concerned. No, he doesn't know. Okay, I don't know.
I didn't write all of it. I've definitely seen parts of it, so I might have created an extension on it at some point.
Okay, my point is that we don't want to repeat the logic, right? So here we have a repeat of the logic. We find a bug, we have to fix the bug in 2 places. We want to extend it somehow, we have to extend it in 2 places. Okay, so what you do with the function overloading is you always make sure that you call one of your function overloads is the one. It's the neo, it's the one, and the rest are just using it in different ways. Okay, that's the best way to do it. There are some extreme cases where that's not possible, and you really do have to have like different logic. Okay, fine, whatever. But in general, it's possible to do this. So here it is, taking the string delimiter, and then, hey, I didn't pass in a parameter, fine, I just default the parameter, right, to the comma, and then it just works. Okay. So last 2 things, I'll hit you with a ton more theory. Okay, the first is the Unix philosophy. So the hacker ethos came out of MIT lab because they had one of the first computers. And so all computer programming kind of sort of came out of these guys just hacking around in the MIT labs. And that created the hacker ethic and the hacker, and then they started leaving, went to other schools, they got jobs, places, whatever, and they brought this hacker ethic across everywhere. And Unix very much has this hacker ethic. And so the Unix philosophy, and I can make these slides available to you because there's 17 rules, but we can go over them right now. So the first is the rule of modularity. So write simple parts connected by clean interfaces, right? So you want little pieces that add up to some great whole, which is really what we're trying to do in Archmage, right? Next is rule of clarity. So clarity is better than cleverness. And so one example of that is like the not operator. So you can say like if, and then some Boolean, I'll say ice cream, and so I'm checking if ice cream is equal to false. I can put a not on ice cream, right? So if not ice cream, I know what that means. You know what that means. But what do I actually code? What I code is if ice cream equals false. That's what I code, because I don't want to be clever. I want to be clear. And there is no doubt about that line of ice cream equals false about what that means. You can get into these funky situations where you have a not and an or and a not, and now it's like, wait a second, what is exactly going on here, right? And it's like, ooh, look, he was able to compress it all down into only 40 characters wide, but now it's confusing. You have unlimited characters, use them. Okay, like you can make your if conditions as long as necessary. And so that's what they're trying to say here. That's an example of rule of clarity. Rule of composition, design programs to be connected to other programs. I don't know how applicable that is, I guess classes to talk to other classes. Rule of separation, so separate policy from mechanisms, separate interfaces from engines. So that is kind of made more data driven. Rule of simplicity, design for simplicity and add complexity only where you must. Rule of parsimony, write a big program only when it is clear by demonstration that nothing else will do. The rule of transparency, design for visibility to make inspection and debugging easier. Rule of robustness, robustness is the child of transparency and simplicity. Rule of representation, fold knowledge into data so program logic can be stupid and robust. Rule of least surprise. In interface design, always do the least surprising thing. There's obviously when you're dealing with an operating system or different pieces of software, the interfaces are really important as they're set. The rule of silence. When a program has nothing surprising to say, it should say nothing. Maybe they're saying, turn off your debug.logs. The rule of repair. When you must fail, fail noisily and as soon as possible. That would be asserts. Rule of economy, programmer time is expensive, conserve it in preference to machine time. I already said that one. The rule of generation, avoid hand hacking, write programs to write programs when you can. Ooh, that sounds nice. Should do that. Rule of optimization, prototype before polishing. Get it working before you optimize it. That's kind of obvious. I mean, that's when Josh was answering like, well, it's got to work first before you worry about readability, right? That's, I think, what they're talking about. The rule of diversity, distrust all claims for the one true way in code. And the last one is the rule of extensibility, design for the future because it will be here sooner than you think. So what are they saying? Like, they're saying roughen the bathroom pipes. That's what they're saying. They're not talking about the, well, what about this? And what about this? And what about this? And what about this? They're just, before the concrete sets, have I made it as easy as possible for the next guy? Okay, and just because that wasn't enough, here's some more rules. You want to program like a Spartan. So you want to minimize your number of variables. You want to minimize your number of parameters. You want to minimize variability of variables. That's the const thing that we saw earlier. You want to minimize accessibility of variables. That's why you put things private. Use early returns whenever possible. Okay, I have seen junior coders put in these giant if conditions. So you go into a method, it starts pretty early on with an if, blah, 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 else, blah, 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 blah. Whereas it would be really easy to just put a, if it's this situation, just return out, like just get out of here and not have to deal with all the rest. So you'll often see that in my code. It's like, there's like 3 things setting up returns before you even get going. Yeah, so you want to get out as soon as you can. And the last one is minimalism isn't always the right choice, but is rarely the wrong choice. Okay, Tyler, I spent 42 minutes. Did I answer your question?
I think so. I think like these last few, like the last slide, like the Unix philosophy rules, I think that really sums up a lot of that. Yeah, I think I could say that at the end that I have an answer now, or I at least have a clearer view. I think what you're saying, that it's kind of fuzzy, that there's no like, this is the 100% the way, you know, like rule 17 of the Unix rules, that there is no one way. I think that's kind of the case here. Yeah, I think that was good. Yeah.